Hello friends, here we are having one question of simply supported beam. The beam is supported at 2 point with the simple support, and the section of the beam is the rectangular section whose width is b and depth of the section is d, and a load of magnitude p, or we can say a point load, is acting along any location of the span. Now we have to find out the maximum flexural stresses developed in the beam. So flexural stresses are the bending stresses developed due to the bending of the beam or by the movement which is acting, or the bending moment which is acting on the beam. So we can draw the simply supported beam like that. Here it is the beam supported at 2 point A and B. It is the span of the beam. Let us suppose that the point load is acting at mid span of the beam at the distance L by 2 and L by 2 from both the supports. Now we can write, or we can find out the supports at the two point A and B. It is RA, it is RB, it is P. Now we can write two equations, that RA plus RB equals to P, and second is at point A we are taking moment at point A of the forces, so RB into L equals to P into L by 2. So from here we can find out RB is equal to P by 2. By putting this into this equation we can find out RA is equal to P by 2. Now we can easily write down that this is P by 2, this is P by 2. Now if we draw the bending moment diagram for this beam, first of all we have to find out the bending moment at any location x from this point A. So if we draw a location x from here and taking the sign convention as across the along the span of the beam at any cross section, if the moment is sagging towards the left, it is taken as positive. Okay, so we can write the shear bending moment diagram, bending along the span at any location x. So we can write that bending moment at any x location equals to P by 2 into x when x is greater than or equal to 0 and less than or equal to L by 2. And also if the section is lied in this portion, we can write bending moment as a P by 2x minus P into x minus L by 2 when x lies from L by 2 to L. Now if we draw this movement along the span of the beam, we can plot it as this is point A, this is point A, this is point B. Between x is equal to 0 to L by 2, we can draw it as a straight line. Again for this section it is also by putting x is equal to L, where x is equal to L we are putting, we will get 0. So the bending moment diagram will be looking like this. The maximum bending moment will be, it is at a point L by 2, x is equal to L by 2. If we put x is equal to L by 2 here, we will find that it is equal to PL by 4. So bending moment maximum will be PL by 4. Now we can use the pure bending equation, because it is given that it is a case of pure bending. The section is prismatic and it is given that it is simply supported. So we can write m over I equals to sigma over y, where sigma is the flexural stresses at any location, at any fiber. For example, this is the section of the beam, it is the neutral axis, because it is B given with, it is given as D. So if we write moment of inertia over neutral axis, it is BD cube by 12. Now this is the section, this is the any location. For example, this is the location of any fiber. So at this location if we want to find out the sigma, and this is the distance of this fiber from the neutral axis. So if we are talking about sigma maximum, so it will lie at y maximum. So here y maximum can be y max is equal to d by 2. So we can use this equation as by putting maximum bending moment as PL by 4 divided by I is equal to b d cube by 12. This will equals to sigma max, and y max is equal to d by 2. If we solve this equation, we will find out that sigma max equals to PL by 4 into b d cube by 12 into d by 2. By solving this, we will find out that this is 12, 4, 3 times. Now this d cancel out, it will be d square, so it will be equals to 3pl divided by 2b d square. 3pl divided by 2b d square. 3pl divided by 2b d square. So if we are looking the option, we will find out that the option D is correct. It is the correct option. Thank you.